All right, I'm going to teach you guys about how you do linear regression when it's on a computer printout. So this example is, if you read up here, they tell you a scatter plot with percent body fat is the y-axis and waist size is the x-axis. So I think it's helpful to even write that at the side. That x is your waist in inches. So you know, like guys' jeans, they're measured in inches, like 6-inch pants or something like that. And then Y is the body fat. So what kind of relationship do you expect? The more, like the bigger their waist, the more body fat is what you would kind of expect, but I mean, there could be variations from that. Okay, so what this is a printout where you don't have to enter everything in your calculator into two lists. So the first hint that I have is constant. This is the y, is like the y-intercept number. Where the waist, we know that's the x variable. And I'm gonna put a star by this line. This line right here, I'll kind of highlight this a little bit. This line is what we're gonna use a lot. And then we're also gonna use coefficient. So kind of thinking back to pre-algebra or something, when you're in pre-algebra and you learn like y equals 3x squared plus 5x, this 3 and this 5 are called coefficients. They're like numbers with the variables. So when we write our linear equation, these two numbers called coefficient are the numbers in your equation. So the one with the x, like y equals mx plus b, this bottom number is the slope. So our equation is y equals 1.70x. And then the coefficient, this is your y-intercept, and it's negative in this case, so negative 42.734. To get the r, you guys know how to do this. I don't have a calculator in front of me, but you would take the square root of 0.678 and then get that as your r value. But then I want to go down to, we talked a lot about slope and context, is this linear regression t-test that we talked about the other day. So we would expect that in this situation, the bigger the waist, the bigger the body fat. So we're going to do a test of greater than. To get your t value and your p value, remember this is talking about slope. So all you have to do is look back in this chart and you look at this bottom line. We can ignore that. We don't really care what this means. There's your t value and there's your p value. Your t value is really high, 22.9. And your p value, we don't know exactly what it is, but we know it's less than 0.0001. So we would reject the null. So I'm just going to create quizzes for you to help you guys, or you're just going to answer some questions based on these. And I thought that'd be an easy way to kind of collect data from you. And let's just go over, I don't really like this one. How about, oh, I like this one. So it's dealing with the speed that somebody's walking in miles per hour with the heartbeat in beats per minute. So the faster you walk, the faster your heart beats, and there you go. So let's try to find our equation from this. I know this one looks a little different, but there's our coefficients right there. Here's our constant, here's our speed, so that's our x right here. So the equation of this line would be y equals, our slope is the one with the x, so it'd be the 16, I'm going to round it to 16.3, plus the coefficient above it, that's your y-intercept, 63.5. Okay, if we decided to run the t-test for this and we would test a positive slope, so I'll just write this down really quick. Your t-value, again, you want to only look in this bottom row, is 19.88. And your p-value, we just know it's really, really small. And then you can reject the null and say that there is a significant positive relationship. So I'm just going to create a quizzes for you. Take it as many times as you want so you get the grade that you want. Good luck.